Right, guys, we are going to get started looking at problem number 25 on the Chapter 4 practice exam for Honors Physics. First thing that we're going to be doing here is reading through the problem, making sure that we understand it, and then put together a free body diagram. So you can all take care of finding out the givens and the needs, but for right now, let's just get that free body diagram created. You'll notice that right here we have the angle, the slope, and the object, force due to gravity, force due to kinetic friction, and the normal force, which is perpendicular to our surface. Next thing that we want to do is write out any relevant equations or relationships that we see based on these forces. What you see here is that we have our net force is equivalent to the mass times the net acceleration. That's the acceleration that's going down the slope. This can also be expressed as the vector sum of our force due to gravity along the x component. Here, that x component is not on a traditional xy coordinate scale, but our x is along the surface. Then we take that and subtract away the force due to kinetic friction. We're going to rearrange this next, and you'll see that we want to isolate our force due to kinetic friction, F sub k. Now that I have F sub k, when you look into the problem, you'll notice that we're looking for the coefficient of kinetic friction, so we also need to identify the normal force. Since the normal force lies along a perpendicular axis to the surface, it's perpendicular to the motion, meaning there's no net force. What we can tell from that is that our normal force is equivalent to the y component of our force due to gravity. Now that I have f of k and f of n, what we're going to do is put together our coefficient expression. Our coefficient of kinetic friction is the force due to kinetic friction divided by our normal force. We're now going to go ahead and substitute in our two expressions above for f of k and f of n. When we substitute them, I'm going to go ahead and expand out f of g to be represented as mass times the acceleration due to gravity. So you'll see here we have mg sine theta minus ma net divided by mg cosine theta. We're going to evaluate this one to see that our force due to gravity is 981 newtons. Now I'll substitute that value along with other relevant values into our expression, and then we'll evaluate that. What we see here is that 414 newtons minus 70 newtons is our top expression. We divide that by 889 newtons. Together in decimal form, we find the coefficient due to kinetic friction is 0.389.